All right, let's dive right into this explainer on Amazon EC2 and how it completely revolutionizes cloud infrastructure. If you've ever wondered how the modern internet actually stays afloat during massive traffic spikes, or how a tiny startup can launch a global application without $1 billion hardware budget, well, you are in the exact right place. Today, we're unpacking the technology that makes all of that possible. Here is our roadmap for today. We're going to start by looking at life before the cloud. Then we'll enter Amazon EC2. From there, we'll walk through the 5-step workflow, look at a real-world application, break down the key features and benefits, and finally check out the wider AWS ecosystem.
So Section 1, Life Before the Cloud.
You know, before EC2, hosting an e-commerce website meant you had to literally buy a physical box. You had to rack it in a freezing cold server room, manually install Linux, configure all the networking cables, and then perform constant hardware maintenance. It was a massive headache. But with the cloud, AWS hands you a virtual server in minutes. You just pick the exact size you need, deploy your code, and easily scale up if a sudden wave of customers hits your site. It is a complete night and day difference. Which brings us to Section 2, enter Amazon EC2. So, what actually is it? EC2 stands for Elastic Compute Cloud. It's essentially a computer running inside of an Amazon Web Services data center. But the cool part is, you have the remote control. You can start it, stop it, or just terminate it completely at any given moment. You get to choose the CPU, the memory, the storage, and the operating system. It's custom built for whatever you need, whether that's hosting a simple website, running a heavy database, or crunching massive numbers for machine learning. I love to think of it like this. EC2 is like renting a fully configurable computer online. You get all the power of a custom machine with absolutely zero hardware headaches. Think about the flexibility here. If you need a supercomputer for just 3 hours to process a huge batch of data, you can just rent one, use it, and give it back. You aren't stuck with a depreciating piece of metal gathering dust in a closet somewhere. Okay, Section 3, the 5-step workflow. It might sound incredibly complex, but we can actually break down the entire EC2 workflow into 5 highly logical steps. It goes, choose an AMI, select your instance type, configure storage, configure your security group, and finally, launch the instance. Let's break each one of these down so you can see exactly how a cloud architect builds a server from scratch. First up, you pick your foundation, the AMI, which stands for Amazon Machine Image. Think of this as your master template. It dictates if you are running Linux or Windows. It contains your base operating system, maybe that's Ubuntu, Windows Server, or Amazon Linux, along with any pre-installed software you might need right out of the gate. For step 2, you define the muscle by selecting an instance type. This ranges from a tiny T2.micro, which is perfect for testing, all the way up to a compute-heavy C7G.large. This is where you decide how much power your server actually needs. AWS offers dozens of combinations of CPU and RAM. Just testing a script, grab the T2.micro. Doing intense application processing, scale up to match the job. Next, steps 3 and 4. This is where you attach data storage, like a 20 gigabyte SSD, which AWS calls an Elastic Block Store, or EBS volume. Then, crucially, you set up a security group. Think of this as your firewall. By default, a server blocks absolutely everything. You have to explicitly tell it to open port 80 for normal web traffic, port 443 for secure traffic, and port 22 so you can securely log in via SSH. Finally, step 5 is just hitting the launch button. AWS takes your entire configuration, finds space in their massive data center, and boots up your virtual machine. They hand you a public IP address, and from your terminal at home, you just run a simple SSH command, supply your secure key file, and boom, you are inside the server ready to get to work. Let's move on to Section 4, a real-world application. Let's take this from theory into practice. Imagine you're a developer who wants to host a Node.js app. You'd literally just launch an Ubuntu instance, SSH in, install Node, clone your code repository, and start your server. In a matter of minutes, what was a completely blank virtual server is now a fully functioning application host. It really is that straightforward. And here is the beautiful simplicity of the architecture flow once you're live. A user types your domain into their browser. That request travels across the internet to your EC2 server. The server processes it using your web server software like Apache or Nginx, runs your application code, and fires the finished website straight back to the user. Seamless! Section 5. Key features and benefits. The true power of EC2 is that it's not just a server. It's a dynamic, globally available infrastructure. Scalability means you can fundamentally change the size of your server with a simple reboot. Elasticity means AWS can automatically launch duplicate servers when traffic spikes, and just as importantly, shut them down when everyone goes to sleep. Add in top-tier IAM security and the ability to deploy your code globally, from Tokyo to Frankfurt, and you have an absolutely unmatched computing platform. Now, with all this incredible power at your fingertips, a very important question usually comes up. How do you actually pay for this? If you're renting supercomputers, is your credit card going to completely melt? Well, EC2 uses a brilliant pay-as-you-go model. Your bill is a simple calculation of the instance type you used, precisely how many seconds it was running, the storage you attached, and the data transferred. And amazingly, small instances like the T2.micro might cost you absolutely nothing to start if you're on the AWS free tier. It shifts IT from a massive, upfront capital nightmare to a flexible, manageable operational expense. Section 6. The wider AWS ecosystem. Of course, EC2 doesn't operate in a vacuum. Think of it as the beating heart of your cloud architecture. Need to store user image uploads? Connect your EC2 instance to S3. Need a rock-solid database? Link it to RDS. Want to keep the server locked down in a private network? Wrap it in a VPC. It is entirely modular, so you can just plug and play with hundreds of other advanced AWS services, like CloudWatch for monitoring or Lambda for serverless tasks. So to wrap up this explainer, the absolute crucial takeaway here is that EC2 completely eliminates the need for physical hardware while maximizing your ability to scale. It literally democratizes computing power. A solo developer working in their garage now has access to the exact same world-class data centers used by Fortune 500 companies. That is a game changer. Which leaves us with a fascinating thought. Considering you can now rent scalable supercomputers with just a few clicks, will physical servers soon go extinct? As cloud infrastructure becomes even faster and cheaper, will owning physical computing hardware eventually seem as outdated as generating your own electricity? It's an incredible shift in how we build the future. Thanks so much for joining me for this explainer, and keep exploring.